Welcome students. Today we will take algebraic method of solving a pair of linear equations. Chapter 3. In this sum we have to find the values of a and b. The pair of linear equations are given. Name them as 1 and 2. Find the ratios of the coefficients of x, y and constant term, and let us find how the steps are working. In the first step, the first ratio is a1 by a2, which is the coefficient of x terms. So the coefficient of x in the first equation is 2 and in the second equation is a minus b. Later, in the second step, we are going to find the ratio b1 by b2. What is b1 by b2? It is the ratio of coefficient of y. So, in the first equation, the coefficient of y is 3 and in the second equation, the coefficient of y is a plus b. And the final ratio C1 by C2 is always the ratio of constant terms. So, here the first equation, the constant term is 7 and in the second equation, the constant term is 3a plus b minus 2. And here is its ratio. Now, what is the condition for a pair of linear equations which has infinite number of solutions? The condition is a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Because this condition is already given in the question. Let us read the question. For which values of a and b does the following pair of linear equation have an infinite number of solutions? So, for an infinite number of solutions, what type of lines they are graphically? Just recall it. Yes, the two lines coincide with one another, then they will have infinite number of solutions. And the condition should be that all the three ratios will be equal. So here are the three ratios which are equal. Let us take the pair of first two ratios and make a group of it. This will be converted into equation 1 and then the ratios of B1 by B2 and C1 by C2 should be made second group. This group will be converted into equation 2. Did you notice that B1 by B2 is repeated 2 times? In this sum, B1 by B2 is 3 upon A plus B, which is repeated 2 times. Because we need two equations to solve by substitution method or elimination method. Then a pair of equation is required. And how can we make a pair of equation? The first will make group of these two ratios and in the second equation will make the group of the last two ratios. It means B1 by B2 will be repeated 2 times. Remember this much. Then the sum is again easier. You are going to cross multiply it. So after cross multiplying, we are getting the two equations. The first equation is 2a plus 2b is equal to 3a minus 3b. Now we are going to transpose 3b to the LHS. So 2b plus 3b will be 5b. Simultaneously, we will transpose 2a to RHS and 3a minus 2a will be a. A is equal to 5b is the first equation. Now let us move to the second equation. Here again the transposing part starts. In the second equation, we are going to transpose 3b to the RHS and 7b minus 3b will be 4b. And 6 will be also transposed to RHS. So minus 6 will become plus 6. And what about the A? Here the 7a will be transposed to LHS. So 9a minus 7a is 2a. So our second equation is also ready. Now very simple it is to substitute a is equal to 5b in the second equation. So wherever you are going to find a, you replace this a with 5b in the bracket. Put 5b in the bracket. So 2 into 5 is 10b. That is equal to 4b plus 6. Now the equation is converted into equation in one variable. Now 10b minus 4b transpose it to the LHS. So the variables are on one side and you get 10b minus 4b 6b, 6b is equal to 6, b is equal to 1. So simple it is. Now put this value of b in equation 1. So if b is 1 then 5 into 1 is 5. Therefore a is equal to 5 and b is equal to 1. Hence we arrived at the values of a and b. The only thing here to remember is for infinitely many solutions we have a1 by a2 is equal to b1 by b2 is equal to c1 by c2. And the second important part is that b1 by b2 will be taken two times, first in equation 1 and again in equation 2. Here we are going to find the value of k. The condition is that this pair of linear equations is having no solution. So what is the condition? If there is no solution, what is the condition of the coefficients of the pair of equations? Yes, a1 by a2 is equal to b1 by b2 but not equal to c1 by c2. It means what type of lines they are? Graphically, what type of lines they are? They are parallel lines. Right. So applying this condition, we are going to proceed. The sum is very simple. Now first you find out in the first step always you are going to find the ratios of the coefficients. In the previous sum also, the first step was to find the ratios of the coefficient of the pair of linear equations. So here are the coefficients in the coefficient of a1 and a2 means the a1 and a2 over here are 3 upon 2k minus 1. They are the coefficients of x. And what about the coefficients of y? Here in the first equation it is 1 and in the second equation it is k minus 1 and here is the ratio. And then finally c1 by c2 is always the constant term. And here is the ratio 1 upon 2k minus 1, 2k plus 1. You can take it directly also. And if you are going to shift this one to the left side, which I told you yesterday itself that you have to shift it to the left side. Then you will get minus 1 upon minus 2k plus 1. And if you take minus 1 upon minus 2k plus 1, then you will get 1 upon 2k plus 1. This step is not that much necessary. You can directly write 1 upon 2k plus 1. Because it is customary to shift C1 by C2 to left side. That is why this step is written. But it is not that much necessary. Okay, now we have arrived at the three ratios and as we can see, we have applied the condition for the ratios A1 by A2 is equal to B1 by B2. This ratio is not at present uh, useful to us because it is not equal to C1 by C2. So it is not going to be useful to us. What we are going to use? We are going to use the ratio A1 by A2 is equal to B1 by B2 and then cross multiply. On cross multiplying, we are getting 3 into k minus 1 is equal to 2 into k minus 1. And then just removing the brackets, we get 3k minus 3 is equal to 2k minus 1. Then transposing minus 3 to RHS, we get minus 1 plus 3 that is equal to 2 and transposing 2k to LHS, we get 3k minus 2k is equal to k. So hence we arrived at the value of k. This sum is very simple. It is on having only few steps. Here we don't have to repeat b1 by b2 two times because the sum is just about cross multiplying and finding the value of k. Here we are only having to find the value of k. In the previous sum we had to find the value a and b, two different values. Here the equation is converted into a single variable that is k. So one equation is enough. Here is an assignment for you. Practice it properly and all the best. Thank you.